So well, good morning, dear students and all the viewers. It's me Indramani Gewali, C Maths teacher. Okay, so without delay, so let me welcome you all in my today's class. Today is the second day of math class. This is compulsory mathematics I am taking for grade 9 for distance learning. So today, in the beginning of the class, let me just have a short recall in our previous class. So in the first day, we discussed. I started from the set, first unit of compulsory mathematics set, and under the topic of set, we discussed some topics. I discussed some topics like what is set. I tried to give some of the examples of set which are related to our daily life or that we can face in our real life. After that, I moved into the types of set, and we had a discussion about different types of set like unit set, empty set, overlapping set, distance set, and so on. There are many. I tried to discuss almost all. I hope I covered off these two topics in our previous class. And I also discussed about what is the cardinal number of a set. Okay, so this is the short recall of previous class. So let me share you now what is today's objective of the class. What is my today's objective? Okay, so today's objective is, you can see in the screen, shortly you can see in the screen. So let me share a slide to talk about what is our main objective today. Okay, let's have a short look in the screen. You can read out what is today's learning objective. So today I will be focusing on these two objectives. So after taking my class, after completion of this class, students will be able to know what are different set operations, and you will also know how is the diagram for different set operations, and you can name them. You can use the terminologies that we use in set operations. And then, though I have discussed what is cardinality, what is the cardinal number of set in previous class, today also, if I get enough time, I will take one or two questions to find out what is the cardinal number of different set. I will try for that, but I'm not sure because I have got limited time. So let me start from the first topic for today's discussion. First is set operations. Set operations. Okay, so what are the set operations? Let me write the first one, union of sets. Second is intersection of sets. Third is complement of sets, and fourth is difference of sets. So these are the four different set operations that we have to learn, that we need to know. Okay, so to discuss about this for different set operations, so I am going to take some examples, and we will also learn it from the Venn diagram. We will use two different ways to learn. One, I will take some examples, I will take some sets and discuss what is union, what is intersection, what is complement, and what is difference. And at the same time, simultaneously, I will be showing the diagrams, like Venn diagrams, to know how is the diagram of different set operations, union, intersection, complement, and difference of set. Now let me go one by one. Okay, so what is union of sets? So it will be easy if I take some examples. I know in maths, if I just talk about the different types of like set or set operations, I know only few of you can understand, because in math we prefer to take the examples and we try to make you understand with the help of different examples and the diagrams if possible. Union of sets. Okay, so let me take two sets. First set is A. The elements of set A are 1, 2, 3, 4 and 5. Second set is B. 6, 7, 3 and 8. Okay, so we can say, so I am taking two different sets, set A and set B. What are the elements of set A? 1, 2, 3, 4 and 5. What are the elements of set B? 6, 7, 3 and 8. So we denote union of set by A union B, and let's write what is union. What are the elements of A union B? So while writing the elements of union of two sets, I am taking only two sets. We also can find out union of three sets, but here I am starting from union of two sets. And in today's class, under set operations, I will be taking examples of only two sets, and the similar examples we can try by ourselves. A union B. So let me tell you what is A union B and how can we find the union. So while writing the elements in A union B, we take either elements of set A or elements of set B or both, but we do not repeat the elements. If the elements are common, we write only once. Okay, so let's write the elements 1, 2, 1, 2, 3, 4, 5, 6, 7 and 8. Let's see again what are the elements of set A. 1, 2, 3, 4 and 5. So I have written all these numbers, all these elements in A union B. 1, 2, 3, 4, 5. And what are the elements of set B? 6, 7, 3 and 8. 6, 7, 8. Here 3 is common, but we do not write the common elements twice. We write only one time the elements. Okay, so these are the elements of A union B. At the same time, let me also tell you now what is the cardinal number. What is the cardinal number of this set? N of A union B is, let's count how many elements are contained. How many elements are in the set A union B? Let's count and write the cardinal number. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 numbers, 8 elements, 8 objects, 8 elements in A union B. So the cardinal number of N of A union B is 8. At the same time, let me display one slide. How is the diagram of union of sets? We can see and we can read out. The shaded regions in the following Venn diagram represents the union of given sets. Here I am taking example of overlapping sets. There are two subsets of universal set U, which are A and B. So as we know, there are three different regions under A union B. That is N only A, intersection and N only B. All these three different regions are shaded in the diagram which represents A union B. Now let me move into the next. After union, let me move into the next, and you can also see the slide number 2, intersection. Intersection of sets. Okay, so it's clear from the word intersection, the meaning is common. Its meaning is common. Okay, so let me take again examples. If the elements of set P are 2, 4, 6, 8 and 10, elements of set Q are 4, 6, 9 and 11. Okay, so look at the examples and just identify what are the common elements. 4, is one of the common element. 6 is another common element in two sets A and B. What are the elements of P? 2, 4, 6, 8 and 10. What are the elements of Q? 4, 6, 9 and 11. So in these two sets we can easily identify what are the common elements. So what are the common elements? Let's write these common elements under intersection of sets. So we denote intersection of set by, let us see, P intersection of Q is, what are the common elements under intersection? 4 and 6 are the two elements which are common. 4 and 6. So at the same time you can see the slide in the screen. There is a diagram and the common region is shaded. Common region is shaded in the diagram because we know there are 3 regions under A union B. There are 4 regions under universal set U. There is only one region here in the diagram, that is A intersection B, which is the common region of two subsets A and B, which is shaded in the diagram. And I'm taking the example of overlapping sets. Here the shaded region, shaded part of the Venn diagram is common part, and this is called intersection. So P intersection Q, the elements are 4 and 6. Now what is the cardinal number of this set? I know now you can easily write down, what is the cardinal number. Here the cardinal number represents the total number of elements contained. What is n of P intersection Q? There are 2 elements, so it's 2. We have 2 elements, so the cardinal number is 2. 4 and 6, 2. Okay, so saying this, now let me move into next, which is difference of sets. Number 3, difference of sets. Okay, so let me take again 2 sets. A is 1, 2, 3, 4, 5. B is 4, 5, 6. Do we know now what is the cardinality of A? What is the cardinal number of A? Simply the cardinal number is the total number contained, 1, 2, 3, 4, 5. So n of A is 5, n of B is 3. But here what I want to say is, what is the difference of sets? We can denote difference of two sets A and B by A difference B, A minus B. If we say difference of A and B, if we talk about difference of B and A, we denote by B minus A. Let me write now what is A difference B. Under A difference B, we take the elements of only set A, which are not the elements of set B. So do we know now? Can we just easily guess what are the elements in set A only, which are not the elements of set B? 1, 2 and 3. 1, 2 and 3. So these 3 elements, 1, 2 and 3, these 3 elements are in set A, but these 3 elements are not in set B. So we say A difference B. So can you have a short look in the slide? So I'm displaying the slide. You can see in the screen slide where the shaded region is A difference B. This is also overlapping set, and it talks about A difference B. Or let me draw a diagram over here. Let me write 2 subsets of universal set U. A and B are the 2 subsets. Now what is A difference B? How is the diagram, Venn diagram of A difference B? Let me set this. So this region belong to only set A. This reason belong to only set A, and this is called N only A or A difference B. Similarly, if we want to know how is the diagram or where to set for N only B, so this is the reason. For N only B, this is intersection and this is complement. I hope you are clear in this topic. So let me move into next. The last one is complement. Complement of set. Okay, now to learn about what is the complement of set, let me take again example. If U is universal set whose elements are 1, 2, 3 up to 10. So what are the elements of universal set? Elements are 1, 2, 3 up to 10. So there are 10 elements starting from 1 to 10. There are 10 elements starting from 1 to 10. These are the elements of universal set U. Let me take a set, subset of U. A is, okay, so 2, 3, 4, 6. So these are the elements of set A. Now can we identify what is complement of A? Can we write the elements of complement of set A? So now what is the complement? If we subtract the elements of A from universal, we obtain the complement of A. So complement of set A we can denote by A complement, comma, we also write A prime. There are other notations by which we can denote the complement of a set. So this is the common symbol by which we represent complement of a set. So let me write the first one, though there are other symbols too, so I'm writing this. This is common. We denote complement by A bar. It's common. Okay, now let's write the complement of set A. Look at the elements of set A. Elements of set A are 2, 3, 4 and 6. So except the elements of set A, now what are the remaining elements in set universal set? These are the complement of set A. So what are the remaining elements after deducting elements of set A? 1. Okay, so 5 because 2 is in set A, 3 is also here, 4 is here, so we don't write. 5 is not in set A, so we can write it under complement. 6 is also here, 7, 8, 9 and 10. Okay, so these are the elements of complement of set A. So let me tell you again. Now you can see the slide. Your slide shows two sets A and B are overlapping. Two sets A and B are overlapping, and the outer region is shaded. This is complement of set A and B. This is complement of set A and B. So these are the different topics. These are the different type of set operations we can learn. We need to learn under the topic of set operations. So let me end this topic here. So I discussed about what are different set operations, and I hope you learned it, and now you will be able to name what are the different set operations and how is the diagram of different set operations, how to share the diagram, where to share under universal set U. Okay, saying this, now let me move into the next topic, which is cardinal number. But this topic is already discussed in different questions. I tried to connect cardinal number, cardinality of set in different examples. Okay, so let's look at the question number 1. So today's main objective is what are the different set operations, how is the diagram, and how to name different set operations. So after completion of this, now we can see a diagram in the screen. General type of questions, question number 1. Let me do this question. Question number 1. Question number 1. So in first question, we can see in the diagram, we can see here are two subsets under universal set U. Under universal set, there are two subsets. So let me draw the diagram. So you also can draw this diagram and write down this question. Okay, so let's write A and B, because let's write same, because I have mentioned A and B in the slide. What are the elements in the common region E and D? What are the elements in N only A, B and C, A, B and C? So what are the elements in N only B region? F, G and H. What are the elements in complement part? These elements are K and J. So we have first question, what is N of A? What is N of A? Means what is the cardinal number of set A? I think so I don't need to solve this each and every questions over here which are displayed in the screen, because I have already discussed what is the cardinal number, how to write the elements of set A, set B, what is union, intersection and complement. Still, this is the first question I am taking here. So let me do first question, N of A. Okay, so let's write first of all, what are the elements of set A? Look at the complete circle of set A. Let's have a short look. The red circle, this is set A, complete set A. So what are the elements? Right, let's write the element A, B, C, E and D. So these are the elements A, B, C, A, B and C. These three are the elements which belongs to N only A. This region is N only A. So here are three different elements A, B and C. This is intersection, N of A intersection B. This is N only B or B difference A, and this region is called complement. Okay, so N of A is N only A and intersection, and A consists of two regions, N only A and intersection of two subsets A and B. Okay, so what is N of A? Let's count and write. 1, 2, 3, 4, 5. So here are 5 elements. So similarly, now what is N of B? For B number, what is N of B? Let's see how many elements are in set B. E, D, F, G and H. So N of B consists of again two different regions, which is intersection and N only B. So there are total 5 elements. In set B. So the cardinal number of set B is also 5, because I explained what is n of A by writing elements of A, and then I wrote what is the cardinal number. So similarly, in B number, you can easily write down by counting what are the total elements in set B. Next is what is n of A union B. For that, first of all, let's identify what are the different regions under n of A union B. What are the different regions in A union B? So I already mentioned it. A union B consists of three different regions, either n only A or intersection or n only B. So under the universal set, there are three different regions lies in A union B. Okay, so C number C, A union B. Let's write the elements of A union B first. While taking the elements of A union B, we take either elements of set A or elements of set B or elements of set A and B both without their repetition. Let's write A, B, C, E, D, F, G and H. A, B, C, E, D, F, G and H. So these all are the elements under A union B. Now, can we write what is the cardinal number just by counting the elements? How many elements are present here under A union B? Let's count 1, 2, 3, 4, 5, 6, 7, 8. So n of A union B is 8 because there are total 8 elements. There are total 8 elements present in n of A union B. Similarly, next one is intersection. Now, I hope we can do this question. It's simple, n of A intersection B. So let's see what are the elements of intersection E and D. There are two elements, so what is the cardinality? 2. Similarly, what is the cardinal number of complement? To write the cardinal number, first of all count how many numbers are present, how many elements are present in the set, in a certain set, particular set, and then we can count and write the cardinal number. So in the complement, there are two elements, K and J. So what is the cardinal number? 2. Similarly, the last one is what is n only of A. N only A is A, B and C. So these three elements, A, B and C, are the elements of set A only. So this is called A difference B or n only A. So what are the elements present? A, B and C. So there are total 3 elements. So the cardinal number is 3. So this is all about this question number 1. Now question number 2 is also displayed in the screen. Let's read the question. Question number 2. Let's read the question. Number 2. Let A and B are the subsets of universal set U. Compute the following set operations with Venn diagram. So we have 4 different questions. So can we practice this question by ourselves? Let's take this question for practice work. Let's take question number 2 for practice work. You can write this question number 2 for practice. Okay, so at the end of the class, I'm about the end of the class because time is limited for the class. So let me just recall today's class. Today, I tried to discuss what are different set operations, and then at the same time, I also discussed what is the cardinal number of set. Under set operations, I discussed 4 different operations: union of a set, intersection of a set, difference of a set, and complement of a set. And I discussed what is the cardinal number of a set. Similarly, I also showed how is the diagram for each set operations, and we talked about one question, and question number 2 is I've given this question for practice work. So thank you everyone. Thank you all for being with me, and have a nice day ahead. We will meet again in the next class Friday, because we have 2 days math class on Sunday and Friday. So let's meet on Friday. Thank you all and have a wonderful day ahead. Thank you all.